In lesson 6, we're going to look at a system of linear inequalities. So far we've looked at systems of equations, and now we're going to take a look at systems of inequalities. And for this lesson, you've already learned how to graph inequalities. So now it's really just graphing two or more inequalities at the same time and looking at where does the shading overlap. If you remember from inequalities, when you graph an inequality, you have shading. So the first thing I'm going to do here is I'm going to look at this first equation, or this first inequality. And when I look at it, I have to figure out the slope is going to be 1/2, and the y-intercept is 3. So what that means is I'm going to start up at 3, and then I'm going to go up 1, right 2. And just continue doing that process. So up 1, right 2, up 1, right 2, up 1, right 2, and then go the opposite direction, so down 1, left 2, and then what you want to do is you want to look and say, okay, before I connect this, I have to decide, is it going to be a solid or is it going to be a dotted line? And if you go back and look at the inequality sign, since this is y is strictly less than, that means that it's going to be a dotted line because it doesn't include the solutions on the line or the coordinates on the line. So I'm going to go ahead, I'm going to connect my points using a dotted line. And then we have to decide on where to shade. So this is where we're going to test a point. Usually the easiest point to test is going to be the point 0, 0. So what you do is you take 0, 0. Remember, you can only test a point that's not on the line. So since 0, 0 is not on the line, I'm going to go ahead, I'm going to test that. So plug it in. So this is 0 is less than 3, which is true. So that means my shading is going to go down over 0, 0. When you shade these, don't shade in completely the graph. You want to just use some lines to represent the shading, especially for systems, because otherwise your graph will get really crowded. So then I'm going to look at the second inequality. The slope of that is 1/2, so up 1, right 2. Y-intercept is -2, so I'll be starting down at -2. And when I look at my inequality symbol, y is greater than or equal to, so that means I want to have a solid line because the points on the line are actually going to be solutions to this inequality. So the line won't just be won't be treated as a boundary, it'll be treated as some of the solutions. So I'm going to start down at -2. You're going to go up 1, right 2, up 1, right 2. Keep doing that, up 1, right 2. And then you're going to backtrack, so down 1, left 2, down 1, left 2. And then connect and make sure that you're using a straight edge to connect these. And you're going to connect these lines using, or these points using a solid line. Make sure that you put arrows on your line, as it does go on forever. And then we have to decide on the shading. So for the shading, again, I can test the point 0, 0. So I have 0 greater than or equal to 1/2 times 0 minus 2, which represents 0 greater than or equal to -2, which is true. So your shading is going to go over the point 0, 0. And now we look for the solution to the system. So where are both equations satisfied, or where are both equations, or where are both inequalities true? So the region where these inequalities are both true is where the shading overlaps. So this area in here is going to be our solution. And you can just write solution in that region. You can write a big S for solution. but you don't need to state it because you can't state all of the coordinates that are in that area. It's going to be an infinite solution. Now take a look too at the lines. The two lines are parallel because they have the same slope. If these were both equations, if this was a system of equations, we would have no solution because the lines never cross. But since now it's inequalities, we're looking at where does the shading overlap. So it's in that region right there. So that's our solution for that. And when you label your graph, I mean, you can label it. It's kind of a weird situation though when you label with inequalities because you're not really labeling the line, you're labeling the region. So you don't have to worry about it for these. I'm just going to not bother with the labels. So let's look at another example here. So graph the solution to the system of linear inequalities. So take each individual inequality and graph them first. So let me just start with this one down here. So x plus y is less than 4. Always get y by itself. So we have y is less than negative x plus 4. My slope then is going to be negative 1 over 1. So down 1, right 1. Y-intercept is going to be 4. So let's start up at 4, and we're going to go down 1, right 1. So down 1, right 1, down 1, right 1. Notice my points are a little off here. And then we have to decide what type of shading. So since we have a strictly less than symbol, it's going to be a dotted line. So let's go ahead and connect these with a dotted line, and then we'll look at the shading. So now I go and I'm going to say, well, 0, 0 is a point that's not on this line. So let's test 0, 0 as a point. So let's test 0, 0. So I'm going to plug it right into the original. So 0 plus 0 is less than 4. You can plug it into the original or you can plug it into your new y, like less than inequality, that's fine. Doesn't matter. So 0 is less than 4. That's true. So that means I'm going to shade over 0, 0. And now I'm going to go and do the same thing for all of these others. So x is greater than or equal to 0. Well, whenever it's x equals, that's going to be a vertical line. And since this is greater than or equal to, it's going to be a solid line. So I'm going to go over to x equals 0, and I'm going to draw a vertical line. Let me just change this to a different color so that it's easier to see. So then when I look at this, I have x is greater than or equal to 0. So you can't test the point 0, 0, but if you need to test a point, so I could test, let's say, 2, 0, point not on the line. So if I pick any point not on the line and I plug it into my inequality, well, this is my x, this is my y. X is greater than or equal to 0. The only number that you're going to be plugging in for is 2, or for x, and y you don't substitute in because there is no y in your inequality. And that is true, so that means I'm shading to the right. Now, a lot of you can just see that, well, x is greater than 0. That means my arrow here on the inequality sign is pointing to the right. It also means x is a bigger thing, so I'm shading towards the larger numbers. And then the last one here, let's say we have y is greater than or equal to 0. So this is again a solid line. And it's going to be a solid line through the x-axis where y is equal to 0. It's a horizontal line. And then you can get your arrows on that. And then we have to decide on the shading. So if you wanted to pick a point, let's say you pick the point 0, 2 this time. So if I have y is greater than or equal to 0, and I plug 2 in, which is my y, This is a true statement. So my shading is going to go up for this one. So then where all of your solutions overlap are actually in this region right here. This is where all of the shading overlaps. So that region is called the solution region. So I'm just going to put a big S in there for solution. So then that would be it for that one. So let's try just a couple more. So example 3, graph the solution to the system of linear inequalities. So I have, again, a solid line through x equals 4. So these ones are actually really quick when you have the vertical and horizontal lines. So x equals 4 is going to be a vertical line. So a vertical line through 4. And then we have to decide on which way to shade. So x is less than 4. So pick an x value. So let's say I plug in 0. 0 is less than 4, so that means I'm shading that direction. It works on that side. If I put 6 into my inequality, 6 is not less than 4, so that's why I'm shading away from 6. And then let's look at the next one here. Y is less than or equal to negative 3. Well, negative 3 is going to be a horizontal line going through negative 3. So let's draw a horizontal line. Again, another solid line because I have the equals bar underneath. So I have, let me just change the color of this. So I have, so now we have to decide on our shading. So y is greater than or equal to negative 3. So pick a y value. So let's say we plug in 0 for y. When y equals 0, 0 is greater than or equal to 3. So that means my shading comes up top. And my solution region is going to be this region where both shadings overlap. So we're going to put a big S in this region right here, right where everything overlaps. And then let's look at one last one just to practice. So this one down here, first thing you want to do, remember, is get each inequality in y equals form. So I have x minus 2y less than or equal to 4. So bring the x over. So I have negative 2y less than or equal to negative x plus 4. And divide everything by negative 2. And here's where you have to remember, it's still an inequality. So whenever you divide by a negative, you have to flip the sign. So it's really going to be y is greater than or equal to. Negative divided by negative becomes positive, so it'll be a positive 1 over 2x minus 2. And remember, the 1 I got because 1 is the coefficient in front of x, so 1 over 2 will be easier when I'm trying to think of it with slope. So now I pull out the slope. The slope is 1 over 2, so it's going to be up 1, right 2. Y-intercept is negative 2. And I'm going to have a solid line for this one because I have the equals included. So start at negative 2. You're going to rise up 1 and go right 2. Up 1, right 2. So plot those points. And then backtrack down 1, left 2. And then you can draw your solid line for this one. And then we have to decide on our shading. So this one, if you want, test a point. So if I test 0, 0, let's see if it works. So 0, 0, if I plug it into either version, the original or the simplified, so I'm going to just plug it into the original, so 2 times 0 is less than or equal to 4. So we get 0 here, it's less than or equal to 4, which is true. So that means I'm going to shade over 0, 0. And it does make sense because our answer is y is the bigger thing. So that means we're shading up. And then we're going to do the next one. So my second inequality. So we have x plus y less than or equal to 4. Bring the x over. Slope is going to be negative 1 over 1. Y-intercept's up at 4. So down 1, right 1, down 1, right 1. And then backtrack, left 1, up 1. We're going to have a solid line at that because of the fact that we had the little equal sign underneath. Okay, so I change the color, get my arrows on there. And now pick a point to test. So again, 0, 0 will work because it's not on the line. So I have 0 plus 0 less than or equal to 4. 0 is less than 4, so that works. So that means my shading is going to go over 0, 0. So start from the blue line and go over 0, 0. And then one last one to graph here. So I'm going to go to my third, which is x is greater than or equal to negative 1. So this is going to be a vertical line going through negative 1. So let's go ahead and draw that vertical line going through x equals negative 1. So every point on this line, x equals negative 1. Let me change the color. And then we'll get our arrows on there. And now we have to decide where to shade. So pick an x value. So let's say I pick 0. If I plug in 0, 0 is bigger than negative 1. So I'm going to shade over x equals 0. You can see this graph starts to look really messy, which is why I'm not filling in any solid shading yet. I'm just doing the lines. And then you have to look at where all of your lines overlap, which in this case it is helpful to see the color. So I see where the blue, the green, and the black all overlap, which is in this region right here. This is where all of my lines overlap. So you get this triangle, and that's going to be your solution. So then you put your big S in there. And you can always, once you figure out the region, you can shade that in, but you really don't want to like shade completely until you figured out the solution region. So then that's it.